Imagine a distant object from outer space entering our solar system. What mysteries does it hide? What secrets could it reveal about the universe? Such an event would not only be a major scientific milestone, but also a huge step forward in our quest to understand the universe. This is the story of Oumuamua, the first known interstellar object to visit our solar system, a discovery that left scientists and the public stunned and amazed. For the first time, an object from interstellar space has been observed visiting our solar system. Since mankind began exploring space, we have attempted to discover whether we are alone in the vast universe. The quest to understand our place in the universe has led to countless missions and research projects. As we gain more knowledge about the planets in our solar system, it has become clear that there is no obvious presence beyond this planet. The limits of our exploration seem to extend only to the limits of our solar system. We have long sought the answer to the fundamental question of whether life exists elsewhere. Our search for these answers continued until our first contact with an object named and #039, Oumuamua. The telescope once again captured images of and #039, Oumuamua, sparking considerable interest and debate among scientists and the public. MIT physicist Michio Kaku spoke out on the matter, announcing that in #039, Oumuamua is back and something unusual is happening. Join us as we reveal the events surrounding and #039, Oumuamua, and explore what it all could mean for Earth's future. Stay tuned for groundbreaking revelations about the return of an #039, Oumuamua and #039, and what it could mean for the future of our planet. In 2017, astronomers made an extraordinary and groundbreaking discovery when they discovered an object called Oumuamua. The discovery was revolutionary not only because of its nature, but also because of the way it reshaped our understanding of celestial bodies. This particular discovery shocked the scientific world for one important reason. It was the first known interstellar object to pass through our solar system. The implications of this discovery were profound, showing that objects from outside our solar system could pass through our cosmic neighborhood. ANAMP, #039. The discovery of Oumuamua marks the first time scientists have been able to study an object outside our solar system, opening up new perspectives for astronomical research. The study of this celestial body outside our solar system is an unprecedented challenge, requiring new techniques and technologies to analyze an object so different from anything we have observed before. Until the discovery of ANAMP, #039, Oumuamua, astronomers had focused primarily on observing and studying objects within our solar system. This focus has limited our knowledge to a relatively small portion of the universe. Despite this, there are still many unknowns to be resolved in this area, highlighting the limitations of our previous observational capabilities. Explore the cutting-edge technologies and methods developed to study Oumuamua, revealing unprecedented insights into the universe. The appearance of Oumuamua has opened up a new category of exploration that allows researchers to gain information about objects beyond our cosmic neighborhood, expanding our understanding of the universe. It offers a new perspective that was previously largely unconsidered, challenging established theories and inspiring new avenues of research. The discovery of an #039, Oumuamua, is certainly of unprecedented importance, as it provides insight into the unknown and raises questions about the nature of interstellar objects. The unique characteristics of Oumuamua have challenged existing astronomical theories, inspiring innovative avenues of scientific research. The Oumuamua expedition has had a significant impact for a number of reasons, including the opportunity to study the diversity and composition of objects in other star systems. The discovery has expanded our view of what is possible for celestial bodies and their behavior, as well as our understanding of how celestial bodies form in the universe. It has the potential to reveal new insights into the conditions under which planetary systems form, uncovering the secrets of ANAMP Oumuamua's composition and what it tells us about the formation of celestial bodies in the universe. By studying its composition and structure, researchers have sought to decipher clues that reveal the conditions and processes under which ANAMP, #039, Oumuamua formed during its journey through interstellar space. The effort involved analyzing data from a variety of instruments and simulations. The object has an elongated, cigar-shaped shape composed of rock and an aspect ratio that distinguishes it from any asteroid or comet observed in our solar system. Its unique shape raises questions about the processes that led to its current state and the forces it encountered during its journey. Oumuamua's unusual shape and composition have raised intriguing questions about its formation and the cosmic forces it encountered. Comets are objects made primarily of ice that form in the outer regions of the solar system, such as the Kuiper Belt or the Oort cloud. These regions are considered the outer limits of our solar system and are home to many icy bodies. They are made up of a mixture of water ice, frozen gas, dust, and rocky material. This composition gives comets their distinctive appearance and behavior. Unlike the unique elongated shape of Oumuamua, comets often have different characteristics in shape and size. Discover the fascinating differences between Oumuamua and regular comets, highlighting the diversity of celestial bodies. In general, comets tend to be more rounded or irregular in shape, influenced by accretion and erosion. As comets approach the sun and heat up, the ice in their cores evaporates, releasing gas and dust particles. This creates a cloud of gas and dust around the core and sometimes a tail that extends away from the sun due to solar wind and radiation pressure. The tail is a prominent feature of comets, making them some of the most prominent objects in the night sky. The striking visual features of comets, such as their tails, highlight the unique properties of and #039 Oumuamua, which lacks these features. The nucleus, the solid central part of a comet, is typically smaller and denser than hair. However, comets can vary greatly in size. A notable example is Halley's Comet, which is known to return to the inner solar system every 76 years. This comet has a core about 15 kilometers in diameter, which illustrates the variability in comet size. Some comets can have even larger nuclei, reaching tens of kilometers or more, although most are similar in shape. Dive into the interesting differences in size and shape between and #039 Oumuamua and other famous comets like Halley's Comet. What sets Oumuamua apart from these common comets is its red color, reminiscent of objects found in the outer regions of our solar system, suggesting a composition or calendar different history. Red suggests a unique composition or specific surface characteristic. This distinctive color may indicate a different chemical or mineralogical composition than typical comets. Despite being close to the sun in its orbit, Oumuamua showed no signs of coma, which clearly showed that it was no ordinary comet but something else entirely. Oumuamua has no coma and a reddish color that suggests a unique composition and history, distinguishing it from typical comets. The absence of this coma is a key factor in distinguishing Oumuamua from other known comets. One of the most intriguing aspects of Oumuamua is precisely that it does not fit the model of a typical comet. Its behavior and characteristics defy our expectations of such objects. Oumuamua, which originally came from the constellation Lyra, entered our solar system, but its exact origin remains unclear. This mystery adds an intriguing layer to the discovery. It sheds light on the mystery of Oumuamua's origins and the intriguing questions it raises about interstellar objects. Oumuamua's journey through space could have taken billions of years, crossing the galaxy before encountering our solar system. This vast journey suggests a complex history and interactions with many different cosmic environments. According to a study published in the journal Nature Astronomy, Oumuamua is likely part of a larger planet in another solar system. This hypothesis suggests that ANAMP, #039, Oumuamua may be the remnant of a disrupted celestial system. The hypothesis that ANAMP, #039, Oumuamua is a fragment of a shattered celestial body offers fascinating insight into the violent processes that form celestial bodies. The intense gravitational force exerted by its host star tore it apart, creating a scattering of fragments. The forces involved highlight the dramatic events that can form celestial bodies. Its journey through interstellar space began when it was ejected from its home system, setting it on a path that would eventually lead it to our solar system. One of the fascinating aspects of ANAMP, #039, Oumuamua, #039, as it passed through our solar system, it unexpectedly accelerated. Explore ANAMP, #039, Oumuamua's unexpected acceleration and the scientific research it sparked. This acceleration intrigued scientists and led to further research into the object's properties and behavior. As mentioned earlier in the video, The object experienced an acceleration that caused a slight change in its orbit from what was previously predicted. This deviation from the expected orbit raises questions about the forces at work. The cause of this acceleration remains unknown and is the subject of ongoing research. Some have speculated that it may be due to outgassing, in which gas is released from the surface of an object, propelling it forward. However, no obvious signs of degassing have been detected. The mystery of Oumuamua's ability to accelerate without emitting any obvious emissions has sparked intriguing scientific speculation and ongoing research. This mysterious behavior has led some to propose alternative theories, including the possibility that Oumuamua is an artificial object, such as a probe or a piece of alien technology. The idea that #039 Oumuamua could be a probe sent by an extraterrestrial civilization has generated considerable interest and debate in the scientific community and the general public. While the theory remains speculative, it underscores the importance of keeping an open mind when exploring unknown phenomena. The idea that we may have encountered evidence of extraterrestrial technology is a fascinating concept that fuels our imaginations. Consider the tantalizing possibility that #039 Oumuamua could be an artificial object, raising profound questions about extraterrestrial life and technology. While the idea of #039 Oumuamua being an extraterrestrial probe is certainly intriguing, it remains just one hypothesis among many. Most scientists favor more conventional explanations, such as whether it was a natural fragment of a larger object or an unusual cometary object. However, the mystery surrounding Oumuamua underscores the need for continued exploration and study of interstellar objects. Each new discovery adds to our understanding of the universe and our place in it. The debate over the true nature of #039 Oumuamua #039 underscores the importance of continued exploration and scientific investigation of interstellar phenomena. Oumuamua's visit to our solar system has provided a unique opportunity to study an interstellar object that challenges our understanding and opens up new avenues of research. Its mysterious nature and behavior have captured the imagination of scientists and the public, highlighting the great unknowns that remain in our universe. As we continue to explore and discover, we may one day uncover the secrets of #039 Oumuamua and other interstellar visitors, further expanding our knowledge and appreciation of the cosmos. Join us as we continue to uncover the mysteries of Oumuamua and the universe, as we seek to answer the age-old question of whether we are alone in the universe.